Uh, we'll start about the online lecture of biochemistry. Myself, Dr. Adak, Professor of Biochemistry, working more than 35 years. Different student I work in abroad and also in the Nepal more than 20 years. We have seen, particularly in the teaching, online teaching, student can utilize their facilities for their practice, for their knowledge. So then I have decided to introduce a plan for me to online teaching like this. So first topic today, urea cycle. All of us is a very common term regarding urea. Urea is a water soluble molecule. It is a water soluble. Water soluble. And the urea molecular formula is NH2COOH. This molecular formula of NH2COOH. Here you see, closely observe, there is a 2 nitrogen. And 2 nitrogen is coming from, what is the source of 2 nitrogen? One is your ammonia, other one is your aspartic acid. This is a amino acid, dicarboxylic amino acid. And the CO, the carbon is coming from carbon dioxide or HCO3 minus bicarbonate. This the source is ammonia, is a toxic. Ammonia is always generated in our system. Ammonia is always generated in our system. It is from protein catabolism. Protein catabolism. For any sort of nitrogen compound or nitrogen compound. Nitrogen compound after metabolism they also generate ammonia. And here I have mentioned ammonia is a toxin. And easily the ammonia enter into the brain and it will give some effect of it. So to avoid this type of nuisance, you need to detoxify. So you need to detoxify. How it can be detoxified? So for that detoxification of ammonia, we will need cycle. That means where the ammonia is neutralized. Ammonia is converted into urea. So this reaction, that's why it is known as a urea cycle, or you can think a removal of ammonia, or you can think detoxification of ammonia. The source of ammonia is your protein. So protein catabolism, protein metabolism, end product is urea. It is a soluble, non-toxic, and also known as NPK substance. What is the meaning? Nitrogenous protein compound, non-protein nitrogenous compound. It means compound having a nitrogen, but it is not synthesized by the regulation of protein synthesis mechanism. That's why it is a non-protein nitrogenous compound. Now, where it will synthesize? It is synthesized in the liver, as well also kidney. But if you see here, it is 100%. Means cycle, complete cycle is in the liver, 100%. Where is the partial? We will do partial. That means some stop or some stage of reaction is not here, but here it is 100%. Another information is here, water soluble compound. So when it is water soluble and excretion. Okay, excretion. Urea is excreted through kidney. So here 2 points is very crucial that we will later clinical part will discuss. When the excretion is decreased, that means retention is increased. The retention is increased, and the level of urea is increased. It's greater than 40 milligram per deciliter. So when the level is increased in blood, that is indicating that the excretory function of kidney is decreasing. That will later we discuss. Today our main goal, how this urea is formed from ammonia, or how ammonia is detoxified, how ammonia is converted into urea, and the main organ is the liver. Here the urea is in the liver synthesized in cytosol, as well also mitochondria. That means the two part of reaction. Compartment is there. Some part of the cytosol, some part of the mitochondria. Now, what are the reaction? First, heading of the reaction. For synthesis, what are the reaction? Number one. First is the reaction. Formation of carbomoyl phosphate. Number one. Number two, synthesis or formation of argininosaccharide. Okay. Carbomoyl phosphate. No, next, just one mistake is here. This is a third. So it is second. Maybe I later to write. Okay, citrulline, synthesis of citrulline. Okay, third is synthesis of argininosaccharide. Argininosaccharide. Okay, and the fourth one is urea. There are 4 reaction steps are there for synthesis of urea. Number one, carbomoyl phosphate formation. Number two, the citrulline formation. Number three, the argininosaccharide formation. Then urea. Then the 4. Now one by one the reaction. You see here, number one reaction. Ammonia, that is a metabolic source that is coming in the mitochondria. Where from this ammonia it will come? It will come from the mitochondria. There is a glutamine or glutamic acid. Okay, glutaminase converted to ammonia, glutamic acid, glutamic dehydrogenase converted to ammonia. So ammonia it will now plus carbon dioxide from TCA side plus 2 ATP, 2 molecular ATP. Then by presence of CPS 1. Okay, carbomoyl phosphate synthesis is 1. So what is the product? Carbomoyl, okay, phosphate. Is it clear? Now again the reaction of the first step, ammonia plus carbon dioxide by expenditure of 2 molecular ATP. By presence of the text, carbomoyl phosphate synthesis 1 enzyme and carbomoyl phosphate 1. This enzyme is your regulatory enzyme. That is, regulation is allosteric regulation. Okay, allosteric regulation. Okay, and this regulator is not N-acetyl glutamine. It is an activator or regulator of the so this is a very crucial step of urea cycle. This step always takes place in the mitochondria. Then another part is also mitochondria. Second, what is that? It is a formation of citrulline. So what will be happen? Carbamyl phosphate, okay, carbamyl phosphate plus ornithine, okay, to form citrulline, okay, citrulline will form. Clear? So for that, what is the need? Here is need your carbamyl phosphate here with ornithine. So form of, okay, ornithine carbamyl transferase enzyme that is known as OTC, or sometimes it is known as ornithine carbamyl transferase or ornithine trans carbamylase. So that is the same OTC will form. Here also need one molecule of, okay, second HOD. Okay, here what is this need? Carbamyl phosphate synthase, ornithine there, they need to form, okay, citrulline. Then citrulline coming out from mitochondria. So these two reaction is a mitochondrial reaction. This is the mitochondria. Now we will come into cytosolic part. Okay, so here is a cytosolic part. So number 3. Now number 3 reaction. What is that? Number 3 is the formation of arginosaccharide. What is that? Citrulline plus aspartame. Already I have mentioned that aspartame contributes 1 mole of 1 nitrogen atom. So here citrulline plus aspartame by, okay, to form arginosaccharide. Arginosaccharide. Clear? So what is that? Here the enzyme. What is the product? Arginosaccharide. So this product is known as arginosaccharide synthase. So here we also need one molecule of ATP. It is converted into AMP plus inorganic pyrophosphate. It is converted into PPR. So you will see mathematically one ATP is here, one molecular ATP is here, two molecules. So 3 molecules. You will see the energy level, then ATP is that equivalent to 2 molecules of ATP. So ATP 2 plus 2. So 4 ATP will consume. Here in the enzyme is arginosaccharide, okay, synthetase. Synthetase is the enzyme. Clear? Now arginosaccharide number 4. What will be happen? Arginosaccharide. Then is the simply hydrolysis. When it is hydrolysis by presence of water, arginase. That enzyme hydrolyzing the arginosaccharide to form urea. So here is the urea will come out, and then again is the ornithine. Ornithine will be formed, and it will go back again in the system, reused, and another molecule of carbamyl phosphate, and reaction will go on until and unless complete ammonia will be detoxified. Okay, so now here another point. When aspartame is using, that is another crucial point regarding TAO, that is the known as, that point is very crucial one. PCSIL with UVSIL connection, relation. What is the relation? The aspartame is coming from PCSIL. So when the aspartame is used, so then it will fumaric acid or fumaric will leave, and that fumaric will enter into PCA cycle. So this is the connection between these two cycles. Okay? So now I draw the fourth cycle. So just by summarizing before we erase it all, we have read with just to feed urea, it is water soluble, it is urea is mainly from ammonia plus carbon dioxide. Ammonia is a toxic, so body has an enough capacity to neutralize the ammonia. So for utilization or detoxification, it will come into the liver. Liver, by through this following four step of reaction, and it will convert it into urea. So I will summarize that cycle about this urea. So it is now in the cycle process. That's why it is a reuse and it is a cyclic way. It is methylene. That's why it is called urea cycle. Now again, okay, this is your mitochondrial part. This is your mitochondria. This is your cytosol. So these two parts already we have mentioned. Here is your ammonia plus carbon dioxide. What do you call? Carbamide. Okay, phosphate. What is that? Caps 1 plus your 2 molecular ATP plus NAD. Carbamide phosphate will form. So then, what will be the then it will convert it into citrulline. Okay, it will convert it into citrulline. For that citrulline, what is the need? Here is the need for that ornithine. Here it will come into that ornithine. Okay, ornithine. Here it will come into ornithine. Here, okay, okay. Here that is the membrane. That is the membrane. It is the membrane of mitochondria cross to transport citrulline to top. Then citrulline cross this membrane. Okay. Okay, citrulline will cross this membrane. Then what will be happen? Then it will come into aspartate will come from PCA cycle. Here is the PCA cycle is there. Okay, aspartate then it will back into fumarate. The fumarate entered and the cycle will go on. So here we will call arginino succinate. Okay, here is the enzyme that I mentioned earlier also. Here is the succinate will form. Arginosuccinate is the name. Here that is the here the reaction that is the OTC, ornithine transcarbamylase, or some book they have mentioned ornithine carbamyl transferase. So now arginosuccinate will convert it into what is that? It is converted into arginine. Arginine will be formed. Okay? Then arginine to hydrolyze. Here, water will come out, urea will form. Here, the ornithine will be back. Here, arginine. Arginine enzyme will back. This is the cycle. Will go on, and then urea will be formed. This is about the urea cycle. Very easy cycle to understand, and that. Now here 2 points just highlight how this cycle is regulated. You see the first here is the regulation. Needs the regulation. How it is regulated this cycle. Number 1 regulator is the allosteric regulation. Allosteric regulator. What is that? NAG. N-A-G. N-acetyl. Okay, N-acetyl glutamate. N-acetyl glutamate is the activator of this cycle. It's regulating this cycle. Number 2 here, 3 is known as the compartmentalization. Compartmentalization. Okay? Compartmentalization. That means here, what is that? Because here the 2 parts, one is a mitochondria, one is a cytosol. So these 2 parts, so entering of mitochondria to cytosol, cytosol to mitochondria. That's the matrix. It is a time dependent and it is the membrane specific is also there. In that way, the reaction is also controlled of that. Third is very important. Second is the second. This is third is another important. Urea excretion. Excretion of urea. Where it is excreted, the level and the regulation of the synthesis is also controlled by kidney. Because the kidney is also excreting organ. Here is also as urea is released, as well also ammonia is also removed. So this level will be decreased, then ammonia formation will be decreased. If it is ammonia is increased, so more reliable, more chances for urea synthesis. So this is about the synthesis of urea and the regulation of urea. Thank you.